So this is section D, part 2, question number 9. It says, how many grams are in a sample of arsenic trifluoride that has a volume of 17,600 milliliters and a temperature of 92 degrees Celsius and a pressure of 108,732 pascals? So this problem has a lot going on. I would say that this is probably one of the hardest problems in this section. So just be aware of that kind of going in. There's going to be a lot of conversions before we can plug it in. But let's just go ahead and get started. So the first thing we have to identify is, are we using the combined gas law or the ideal gas law? So the way we know we're using the ideal is because it gives grams. So anytime grams or moles is mentioned, it's definitely going to be the ideal gas law. So it's going to be PV equals nRT per Vnert. And we have a lot of variables we're going to have to convert. So let's go ahead and write them all out. So PV nRT. One that we know we don't have to convert is always that gas constant, 0.0821 liters ATM per Kelvin mole. And keep in mind that this gas constant is actually giving you all the units that you need to have to plug in. So we have to have our volume in liters, our pressure in ATM, temperature in Kelvin, and our quantity in moles. So it says how many grams. So we're actually going to be solving for moles first, and then converting it to grams at the end. We keep going, has a volume of 17,600 milliliters, a temperature of 92 degrees Celsius, and a pressure of 108,732 pascals. All right, so we're going to have to convert all of these things first. So let's start with the easiest one. Let's do temperature. That's a very easy one. We're going to convert to Kelvin, add 273.15. We're going to say 92 plus 273.15 is 365.15 Kelvin. Let's do the next one. That's going to be a little bit on the easier side. Our volume. So this one is just going to be a basic metric conversion. We're going to go from milliliters to liters. So you always start with what you're given. So we're going to have 17,600 milliliters. We want to convert from milliliters to liters, so we follow through milliliters up top, go to milliliters on the bottom, liters up top. The bigger one always gets the 1, so liters is larger. Milli means 1,000. And when we plug it all in, milliliters cancel, and you'll get 17.6 liters. Awesome. Our last one is a little bit trickier. So our pressure, we're going to have to actually do 2 conversions because we do not have a direct conversion to ATM from pascals. The only conversion we have is from kilopascals to ATM. So keep in mind, to go from pascals to kilopascals is just a metric conversion. That prefix kilo means 1,000. So we're going to do 108,732 pascals. So the first thing we're going to do is follow through pascals up top down to the bottom. And we're going to go to kPa, kilopascals first. So the larger one gets the 1, which is kilopascals, and there are 1,000 pascals in 1 kilopascal. At that point, we can follow through with kilopascals and put ATM up top. When we do this, 1 ATM is equal to 101.3 kilopascals. So if you don't have those conversions, I'm going to upload a reference sheet, so make sure you check that one out. Everything cancels out. Let's plug it in. So we have 108,732 divided by, open parentheses, 1,000 times 101.3. And we get that this is equal to 1.07 ATM. Awesome. Sweet. So now all of our units match with our gas constant. So we have liters, ATM, Kelvin, and again, we're going to solve for mole and then convert it to grams. The last thing I want to take a look at is what that compound is. So it's arsenic trifluoride, so it's going to be a covalent bond, so arsenic, AS, trifluoride, fluoride is F, that prefix tri meaning 3, There's going to be 3 of those fluorines. So don't forget that that's our compound. Since we're solving for N, let's go ahead and manipulate the equation before we start plugging in. So to do that, we're going to divide both sides by RT. That way they cancel. So go ahead and rewrite that equation. PV over RT equals N. Now let's just go ahead and plug it in. Solve for N, which is moles. So our pressure is 1.07 atm. Our volume is 17.6 liters. Our universal gas constant, 0.0821 liters atm per Kelvin mole. And our temperature is 365.15 Kelvin. And that is equal to moles. Let's go ahead and plug that into our calculator. So we're going to do open parentheses, 1.07 times 17.6, close parentheses, that's the whole top, divided by open parentheses for the bottom, 0.0821 times 365.15, close parentheses, hit enter, and we get our answer in moles. So 0.628 moles of arsenic trifluoride. Again, for moles, you always want to make sure you go out to the 1/1000th, just because moles is such a large unit, so you want to have it as accurate as possible. Alright, so our last step, the problem did not ask for our answer in moles, so our final step is going to be converting from moles to grams. So we're going to say, I'm going to do it down here at the bottom, 0.628 moles of arsenic trifluoride. So follow through. Moles up top means it's going to the bottom. Grams going up top. Anytime you go moles to grams, moles always gets a 1. So let's find the molar mass of arsenic. Arsenic trifluoride. So there's arsenic. So we're going to say 74.92 plus, there's 3 fluorines times 19. So 131.92. So our last step is to plug that in. So we're going to do 0.628 times 131.92, and we get that the number of grams of arsenic trifluoride is 82.85 grams of arsenic trifluoride. Awesome. It's a long problem, and this is absolutely as hard as it gets, so keep that in mind. This is it. That's as hard as it's going to get for this problem.